Hi everyone, welcome back to Global AI Community on Virtual Tour. Gosh, I'm not even sure what hour of streaming we're at anymore, but there has been some incredible content, and I'm pretty sure that this session won't fail to impress as well. We are joined by Bruno. Hi Bruno, how are you doing?
Hello everyone, I'm fine, thanks.
Good stuff. Bruno, I've met Bruno a few times. I've seen him speak a few times. I'm very, very excited about this session to do with drones. Bruno is a regional innovation lead at Avanade in Canada and has been a Microsoft MVP, so our most valuable professional, for 12 years, which just shows, Bruno, your commitment to the community and the amazing different projects that you come up with. How is everything going? Where are you based? Sorry, Bruno.
I'm in a small town near Toronto, Canada called Burlington. Yes, it's fine. Here in Canada, we have sun, we have good weather today, so it's fine. Next week, it seems that we are going to be back to snow, but hey,
Oh,
so far, so good.
oh gosh, so you're on the other side of the planet. What time is it there?
Here is 2 p.m.
2 p.m. Okay, so it's 7 p.m. here in the UK, but we also had sun today, so that's always a treat, isn't it? Feel closer than ever. Okay. Well, without further ado, Bruno, massive thanks for joining us. We're really excited to see what you're going to do with these drones. We got a little sneak peek of what might happen in this session. So yeah, feel free to take it away.
Okay, thank you very much. And hey, hello and thanks everyone. I have seen, you can see here that I have my camera with a small layout. I have another camera there. It's because it's tricky to show the drone around in a small space, but I hope that you get the feeling of what I have. As Amy said, my name is Bruno. It's a pleasure. I can't thank enough all of the organizers, the host, and the attendees here. It's a pleasure to be here. And I am going to talk about how you can use a drone and apply some AI with the stuff that you're doing with the drone. And because we like technology, I will also tweak here this a little, talking about containers and how you can do these other kind of things. And I will start with a big warning here. These demos are just for fun. Do not take this seriously. And I also have some animations here, which are not very good. But if you want to learn, I like to learn a lot, basically having fun. And that's why I choose this, because to learn these kind of things. Most of the things that I'm going to show today are using Python. And I am not a Python developer. I've been doing Python for the last 3 years. It's a nice language. I am mostly a C#, C++ guy, but Python is very easy to understand. So I hope that everybody can understand this. I will also use some couple of community services to basically make my drone more intelligent. So if you already know this, it will be good for you. And I will basically cover very, very high level definition about how face recognition works, how communication protocols like TCP or UDP works, and how Dockers work. I am not going to go deep there, but I hope you can follow this. And again, one more time, everything that I'm going to show you here is for fun. This means basically represent the output of my project. This is me giving coding advice, but do not trust my code. You are going to be able to play around with your code and also play around with the drone. Because when I started this, it was, I don't know, it was a couple of months ago or a long time ago, one colleague here in Canada told me about this drone. And he told me that, hey, do you know that DJI Tello has this not expensive drone? This is $100 drones, $100 US dollar drone. It's very small. You can see here in my hand. You can grab it here. So you can fly it around. You're not going to have problems usually with big drones that have the police asking you for whatever. This is a small drone. It's cheap and also has a lot of cool features. Like an example, the battery is 10 minutes or so, which is great because it's cheap. If you want to get extra batteries with a couple of $10 mark, you have 2 or 3 more more batteries, and you can play around. It has a lot of cool features. So it has a camera, which is the stuff that I am going to show today. In the front, you can see there in the slide. It's not a very good camera. It's not a high definition camera, but it's good enough to play around. It gives you the chance to connect to the drone via Wi-Fi, which is basically allows you to get in the specification said 100 meters. I'm not sure about that. It's less than that, but hey, still good to play around, and you can do a lot of things. And by the way, all of this info is in the official Rise DCI tail or product page. But what I really like when I started to play around with this is that somewhere there, somewhere in the documentation, the DCI team claims that you can program this drone using Scratch. Scratch is an amazing tool, mostly used for kids, because you can program in Scratch using blocks, so you can connect the blocks and define actions or do loops or do conditions, and you can start to interact with the drone. So when I start to see this, I say, hey, if you can use Scratch to do this, there may be something there. And even if in the official page they claim that they have an SDK, I couldn't find it. There is no available SDK there. There are some specifications, so if you want, you can print your cover here, so you can create your Iron Man version of the drone. You can do a couple of things, but there is no SDK. But the cool thing here of the drone is that somewhere there, deep in this website, in the product website, you have a PDF which explains how to connect and how to interact with the drone. So basically here, when you have connected the drone, when you start the drone, it will create a Wi-Fi hotspot. So you can connect to this Wi-Fi hotspot. And when you are connected to this Wi-Fi hotspot, you can open a socket in a specific port and start to send command and start to receive data. And then you can start to play around with your with your drone, which is freaking amazing. And there are a couple of ways, there are a couple of things that you can do here. Before moving forward, just a disclaimer here. This is going to use UDP. If you ever work with communication protocol, UDP is one of the worst, because you send information and you're going to see this later, and you don't know if it is there or not. It's not like TCP where you have a handshake. UDP, this is a very old joke. I was trying to find the source of the joke. I couldn't find it, but this is what it is. It's UDP, and you need to put a smile and move on. So everything that we're going to do today is going to use UDP. I also do this in Python, and I'm going to tell you why later. But once you have UDP defined, you know that you can start to do some connections to the drone. And in my specific scenario, the way that I set up this for this demo was like this. Because I need to be online, I can't connect to my home network via Wi-Fi and the drone at the same time. I can connect only to one. I have a mesh at home of Linksys Velops nodes, so I connect one of my nodes using network cable to my computer. I have a gaming computer for this, and then I connect here to the drone. And there are a couple of lessons learned here. So let me show you what I do when I connect to the drone. So first thing first, I am going to turn on the drone. There's a small button there, and then when you turn on the drone, it's off. They have a crappy LED blinking there. One is blinking, you can start to connect. What I do here all the time, I basically ping my drone. I have here my drone, and I started to ping my drone. And then go into my terminal. I have here in my terminal, I have a couple of commands saying, okay, let's connect to the drone. As you can see here, the drone is connected there. And the way that you can do this in a lot of time. I have a PowerShell running this for every 10 seconds, so I never connected, because the drone, if this is not working, it will automatically shoot off. Sometimes it shoot down, you don't know why, so there are a couple of tricks here. But right now in my computer, where is my settings? Here are my settings. Right now in my computer, as I said, I am connected to the Ethernet for internet and to the drone. And there it is, and I have access to the drone. So it's very, very easy to connect, but you need to keep this connection alive. So what is going to do next? Now we have this, we can start to create a connection to the drone. We can start to send commands to the drone. This is the moment that we need to start to open sockets. And there are three sockets that we need to open. One is for send commands, and we are going to receive, every time that we send the command, a response which is going to be okay or error. We don't know why is the error, but that's what we have. The other port that we have open is to read the states from the drone. There we can read the states to know the battery charge, the temperature of the drone, how high it's flying or not, the accelerometer movements. There are tons of information. And the third socket that we can open is to get the video feed, which is kind of the cool part, to connect to the video feed and start to work. So initially, what I am planning to do is to create a program which is going to have two main commands. One, to send commands, another to read commands. And the hello world with the drone is send the start command and then make it fly. But I ordered a second drone to have a backup for this demo. because we live in these crazy days, it haven't arrived yet. So I am going to leave my flight demos to the end. I don't want to broke my drone right now, so I am going to basically start with the, hey, let's try to see how much battery is in the drone. So let's code. This is going to be mostly code today. I don't have much more slides. So I am going to go to code. Let me move this to my other monitor so I know when my drone is alive or not. Let me go here. I am going to create a new Python file. Oops, I am caps lock enable Python file, demo file. And what I am going to do, I am going to start to use a couple of codec snippets. First thing that I'm going to do here is I am going to make a couple of imports. Very simple sockets to open sockets, times, because I need to create some easy routine to basically handle timeout, and threading, because all of this reading is going to be in different threads. Then what I am going to do, next step, is to start to do, hey, let's create a couple of receive functions. So what I have here, remember, I have two sockets, one to receive the data that I am sending, fly, and I have OK or error, and the other to read the values of the drone, the battery, the temperature, etc. So I have both of them here enabled, and they are going to be activated later. This is very simple code. And then let me create a couple of functions for send commands. I have a little more code here. Let me make this bigger. I have send the code here, which is going to send the command. The command is just a string. I need to convert the string to UTF-8, but just a string. And I send the command. And what I am doing here, I implement a simple line of code to basically, once I send this command to this socket, I wait 5 seconds to see if I have the OK or an error or a timeout. It's very, very simple. And then I have the send command, which is the same, the control command, because there are different type of command that you need to send. But as you see, so far is very simple to use. So let's talk about the connection. How I define the connection to the drone. I have my IP, I have my 2 ports. I am not going to do video right now, just sending commands and receiving commands. And I opened these 2 sockets here. One to send and receive commands, the other to send and receive the states. It's as simple as this, and the next step will be, okay, but these need to listen in different threads. Remember, I told you I am not a Python expert, but for me this was a chance to start to learn and start to understand how threads work in Python, how to work with sockets. I've learned a lot here, and what I am doing here, basically, I create 2 threads to read the states and to receive data, so I can have this enabled all the time. Final step here is, let's create an application. And my application is very simple. It's basically going to start with sending a control command. This is the first command that you need to send to the drone, because that enables the SDK mode. And then I am going to read the battery. Sleep for 5 seconds, just in case. This is defensive programming, and print the battery value here. So I have this. So let me go back here. Let me show you. My drone is disconnected, so I need to go back here, turn the drone on, and when it's on, I need to start to connect again. Once my ping is up, I'm going to show the ping result here just to see what's happened. When the drone is connected to my machine, there it is. What I am going to do is I am going to go here, go to events, and I think I have here Python, my demo application, and when I run my demo application, it's going to wait a couple of seconds, 1, 2, 3, 4, 5, something like this, and it's going to show me my battery. My battery right now is 92%, so I am connected to the drone. But the nice thing here, the cool thing is, here my battery, as you can see in the code, is the item number 21 in a full list of information that I have from my drone. If I go to see everything that I have here in my drone, you will see that I have, and I hope I'm still connected. I may be disconnected. Yes, I have a timeout. I need to connect again. So let me put this in the second monitor so I know where I am all the time. And connect again. There it is. And I have all of this info coming from the drone. I put this down because I want to show you how this works in real time. Let me put this in 25 seconds. I'm launching my application. The first item that I have there is the pitch and the roll and the yaw. This is accelerometer. This is the 3 axes of the drone, and you can see how they change in real time. So I am reading the information of the drone kind of in real time. I am moving the drone. I will have some negative. I think the roll should be negative. Yes, it's negative there. Then it comes back. So I am reading info in real time for the drone. And again, it's just a couple of lines of code. Is kind of very, very easy. The key thing here, the tricky thing here is how you keep this alive, how you handle this. If you are constantly working with the drone, it's not going to shoot down. But I have a lot of info here. I have accelerometer information. I have vector information. I have temperature. I can't remember which is the difference between these two. Somewhere in the SDK I explain it. I have the battery. I have the barometer. I have the internal time. There is plenty of information that I can do. So imagine that you have this drone flying. You can start to read this info, save this info to a couple of files, and analyze this information to detect some anomalies or whatever. So this is the moment where I should probably send and move to the other command, which is the take off and make it fly. I will leave it to the end, but this is the moment where the people start to clap. Hey, we are connecting to this crappy small drone, and we are getting info from there. So let's move forward what we can do. So hello world, not take off and fly, get battery for change. But the important part, we can access to the camera, and the camera is enabled in port 1111151 via UDP. This is the address that you need to use. I tried to connect at the beginning to this address using tools like VLC. Didn't work, and it's sad because VLC works almost for everything, but it couldn't resolve this. And then I started to read, and I found this set of tools, FFmpeg, and I found a way to basically connect to the drone when it's open for the stream, and then show the stream. But as you can see in this GIF in the site, there is almost 3 or 4 seconds of delay versus the real feed and the one that I get from the drone. I never know why this happened. I try a lot of parameters, I try a lot of things, but then I remember, you know what? I know OpenCV. I did a lot of OpenCV as C++ a long time ago, so maybe I can use OpenCV to access to the camera. And it was amazing. And as I said, this is one of the I choose to go through Python because OpenCV in Python, there are plenty of things to do. There are not so many to do, not so many samples in C#. There are plenty on C++, but you need to write a lot of code. So I get a perfect balance between OpenCV and Python to work around with this. So let's create a demo to access to the camera. So let's go for camera.py and let's go for the initial set of code. The initial set of code is very simple, just like the previous one, with the main difference that I am importing OpenCV. This CV2 is OpenCV, but I have my receive data functions, I have my send command functions, I have the connection to the drone, I have the thread. It's just the same set of code to access the drone. The main difference here right now is that I need to start my command to my connection to the drone, saying that, okay, I am going to start to send command to you. This is SDK, but also enable the stream. So when I send the command stream on, it's going to enable the stream so I can access the UDP in the port 11,111 to start to show this. So here, what I can do is I can start this camera from the drone, and the camera is in this address, and then with just one line of code, I can capture this as it was a standard camera in OpenCV, and I can start to show the camera video feed from the drone here with OpenCV. So, oops, I'm sorry. This is the way that you can display the camera. Basically, I am going to use the battery just to have a track of how much battery I have, or I need to change to the other one. And in an eternal loop, while true, sorry about that, remember, crappy programming, you're not supposed to do this. Don't do this in production. I am going to read the value of the battery, and I am going to open a frame via UDP from the drone. I am going to resize the frame. I don't want the full resolution, 640 and 480 is fine for me, and I'm going to show this. And I am going to stop I'm going to show this, and I'm going to stop the execution if I press the letter Q. And the last thing that I need to do, I need to basically send a command to the drone when I stop the program, saying that you need to stream off. If I don't send this and I learn this in the bad way, sometimes it works, sometimes it don't work. So it's kind of a creepy scenario. Reading the non-official SDK, I realized that I need to send this command to the drone. So here, what I can do right now, I can enable my camera. Let me see, I am not connected. So this is, you're going to see me doing this a couple of times today, basically connecting to my drone. When it is ready, and when it's ready, I can start to program. It's not connected yet. One more time. There it is, connected. So now I'm going to launch the camera. When I launch the camera drone, I have all of this info because by default, OpenCV is in demo mode. It's in verbose mode. But you can see here in the bottom right corner that this is the camera feed, and this is showing me. This is my face there. I'm sorry about that. I couldn't find someone better good looking. But I can show this real fast. And you see here that I am moving this, and the response rate is kind of nice. It works great. It's unless you tweak this a lot, it's worked great. I am trying to move this fast so you can get the sense of what it's doing. But you know what? I have a camera right now. So right now I can start to play around with a lot of things. This is the moment that you start to have fun because we have information and we will have an image. We can do a lot of things. If you want to have a sense of how fast this is working, let me stop this, close the program. I have here, I think it's the 31. I have here the, I am disconnected. Yes, let me to connect again. I have here one extra example, which is going to show the same camera of the drone, but with the frames per second that I am processing. And as you can see in a couple of seconds, if it's connected, here with a smaller size, I have an average of 100 and 200 frames per second. This is freaking amazing. It's very fast. Of course, if you put this in a smaller resolution, it's going to work faster. So this is something that you can really do. And remember, again, this is a crappy $100 drone. Hey, my Captain America shield there. This is a $100 drone, and you're going to start to do things. So this is the moment when I realize, okay, I have this, I have all of the cameras and the demos that I have. What's my next step? What's the first thing that you can do here when you are presenting? You have the camera, you have information. Let's go to do some face detection. Let's try to detect faces. Do not get closer with the drone to a face. You're probably going to hurt yourself. But hey, this is nice. By the way, this is a very old GIF. I love this GIF. I think I see this 4, 5, 7 years ago from Boris Babenko, but it's face detection. This is what we are going to do. And you can do a lot of things. I write a lot. I'm going to share the resources later. How you can do using Python, using OpenCV, using community services to do object detection, facial features, doing a lot of things. I love about facial detection that you can do this in several ways. You can not only detect faces, you can recognize faces, you can detect facial features. This is my little daughter. Sorry, I need to put my daughters on stage from time to time. But you can do a lot of things, and it's very easy. You only need a couple of lines of code. And even if you have pre-packaged tool to do this, one of the easier things to do face detection is using something which is very, very old, which is the Viola Jones object detection framework from the 2000s. And I am not going to go deep here to explain how this works. It's basically you convert an image to a grayscale image, and detecting patterns, as you can see here, you can detect the eye line and the nose, and that's a face. So this algorithm is almost 20 years old, and it works great. But the best thing about this is it's including OpenCV. So you can do open detection in OpenCV with just 2 lines of code. And it's all based on the hard cascades, which are a set of files that will allow you can train this file to recognize faces or other things. And it's very easy to use. So let me show you how this works in a real code. So here I have a sample. It's the same sample that I opened before. I'm going to do this with a bigger frame. Instead of 320, I'm going to go for 640. But the main difference here is that I am going to, before starting to show the camera, I am going to initialize a cascade, a hair cascade, using this file. This file is a file that is part of OpenCV. There are plenty of these files in internet. You can create your own with images. You can train your own image recognition systems. And I am going to use this, which detects faces, which is great to detect faces. And I'm going to create this object, which is a cascade for faces. Once I have this, and I have my frame that I get from the drone, my next step will be, I will convert the frame image in color to a grayscale, and I am going to use this to detect faces. And that's it. Once I have my faces detected, if there is a face there, I am going to show this in the frame on the OpenCV. 5 more lines of code, and I can detect faces. So this is kind of great. I am disconnected, of course. This is turned off. This is what's happening in demo mode. So I need to connect again. Sorry about that. Not here, not here. I'm looking at the ping window in my other monitor. There it is, it's connected. So I am going to run the face detection so we can take a look how this works. So, sorry. So I am going to run the face detection sample. It's going to open, connect to the drone, open the camera, do all of the things that I just explained. And when I get my frame here, we are going to see that at any moment here, I should get my red frame with my face. There it is. I don't want to push this in another. I don't have anyone else with me here. I don't know if it's I pick up Hulk. No, it's not working. I don't have light enough here to show Hulk, but it's here working. And also you can see that it's kind of fast. It's nice. I have 40 frames per second or something like this. I have another one doing frames. But again, the only thing that I do here, the only thing that I did here is add a couple of lines to detect faces. I have more sample here. I'm going to share this later because there are other hair cascades to detect smile, so you can detect the face and the smile. I even find one which is for detect the banana. So this one will use a hair cascade to specifically created to detect bananas. So here, if in the point of view, I have a banana, a plastic banana here. I put my banana somewhere here. It's going to detect the banana. The main issue that I have with this is there are a lot of false positive here. If I put my elbow here, my elbow sees a banana. So there are a lot of things because small pieces, small parts of the images allows you to be detected as a banana or whatever. So what I can do here, and let me show you the code of the banana because it's very similar. I initialize, first of all, a face cascade to detect faces, another cascade to detect bananas. And once I have my frame, first I go for faces and I put faces. And by the way, in this one, I put the frame and I also put the text saying that this is face. And I detect bananas, and if I found the banana, I put the green frame and I put the banana. So it's very easy, very simple, but as I said, the small ones give you false positive, false results. So what you can do is use another option that you have in OpenCV saying when you are detecting objects in my image, only detect objects which are bigger than, or detect objects with the neighbors are 5 or 10. So there are a couple of options here that you can play around, and it works very, very great. So in a real scenario, let me stop this. In a real scenario, this is the 44. So let me connect back to my drone. It's turned off, turned on, and connecting. Sorry about that, but this is the day of working with this. Not yet. In a real scenario, what I am going to find is that in this, using the new one, it's only going to detect bananas which are bigger than a specific size, and it's going to work great. But it's not what you need to do. I mean, hair cascades are great, but I still think that we can do better. So here, it's going to open soon. There it is. Let me put this one here. My face, somewhere there, I have a face. Have a banana, which is fine. If I put the banana in the back, it's small, it's not working. When I start to get bigger, it's starting to get detected. So it's kind of work, but it's not how you are going to really do a project with this. I strongly recommend people to play around with hard cascade because you are going to learn a lot, but it's not very useful for a lot of scenarios, especially when you have a lot of different things. What I found easier for me, remember, I am not a data scientist, I am a crappy developer. What you can do here is to build your own image recognition model. And the ABC, people very smart told me that the ABC in the machine learning world is start with your data, build your model, and use your model. So lucky for us, there is a service in Cognitive Services, which is called Custom Vision, and it has the ABC. I will upload images. This is going to be my data. I will train my model with these images, and I will have at the end an endpoint, and a couple of other options to use this. So what I did here is I used Cognitive Services, and I think yesterday, Anthony, later today, Laurent, and a couple of them explained how to do this. But I created a model, specifically designed it to recognize, to recognize my MVP logos that they have in the back. I upload, I think it's 15 or 20 images here, and I select each one of these, my MVP friends here, MVP awards, to be selected. As you can see, I have here this one fine, this one with much reflection, a single one, a bigger one, some are perfect, another are a little rotated. I trained this, took me 5 minutes, 20 minutes, and when I have this and I train my system, just the first iteration was good enough for me. Sometimes you need to add more pictures, remove images, start to work with this, but this is the one that I have. It has an 83% of precision and 93% of recall, which is freaking good. I was expecting to do this much more time here, so this is very good. And the idea here with Custom Vision is that I can go here and browse, upload an image here, in example, and when I upload an image, the Custom Vision service, based on how it's trained, is going to recognize the models. It's recognize the MVP awards, and it's going to give me results. So as you can see here, I have the result for these recognized ones, and I also have the probability. So for the bottom left one, we are 70% sure that this is an MVP award, but for the first one is 96%. So it's very good. And there are several ways to use Custom Vision. And again, people talk a lot about this. I am not going to go deep. One of the ways that we can use Custom Vision is from here, I can publish this iteration and I can get a URL to use this. That's amazing. The only thing that I need to do is post an image, HTTP post to an image, and I will get the result if they found or not MVP logos in this case. But, and this is the crazy good part, I can also export this to be used as a TensorFlow model. So if you know TensorFlow and you work with Python, you can use this. By the way, I didn't even know that we also have the TensorFlow for JavaScript. For all of you JavaScript lovers that are crazy because JavaScript is amazing, but I never get there, you have the chance to use TensorFlow.js to do this. So you can create with 10 lines of code a page to detect these kind of things. We have TensorFlow, we have TensorFlow Lite, we have a lot of things that we can use here. I really like two here. One is Onyx, because Onyx is supposed to be a standard that you can use almost everywhere. And the other that I really like is export this as a Docker file, as a Docker image. We can use this, and you have 3 versions of Docker. You can export and use Docker on Linux, on Windows, on a Raspberry Pi. If you have a cool Raspberry Pi 4 with a big cooler on top, you can basically put this on fire, recognizing images, because it's really work. So what I did, I export this for I think it was Linux, I can't remember which one, Linux or Windows, I can't remember. I have Docker running in my machine, and what I've done here, let me go for Docker. Let's clean this a little. I have a couple of images in my machine. Let's add some zoom there. So I created 2 images for me. I was playing around. First one is the same image published in port 80. I am using the port 80 in my machine for other things. So I created a new one I tweak a couple of things, and I have here the 1.1, and this one is right now running in the port 8070 in my local host. So I'm running this. This is something exported from from the Custom Vision, and it's basically expecting for me to post an image, and it will give me results. If we want to see how this works, what I can do right now, I can pick up a tool like Postman, which allows us to do these kind of things. I can select a file, so let's select this one. I am posting this, I am using my local port for this. I am going to send this, and this is calling my local container, and this is giving me this raw result. This is the result that I have here. So I have a prediction here with an MVP tag, with an MVP logo, 96% for an MVP, and this is the location of the bounding box, so I know where to draw this, where is located here in the image. If I go for a bigger image, I'm sorry, let's select one with just one. This one example, and I post it here. It will give me just one here, so I have my MVP very low. I don't know why, so I maybe need to work with this 24% that is working, and this is the location where it's located. But you get the sense. I have a local server in my machine running, try to detect this. So what I've done here, and I am getting close to the end, what I've done here is I created a couple of examples where I basically, let me go up here, I'm sorry, go down, where once I read my frame from the camera from the drone, I save and I will tell you why later. I save the file locally, and then I open the file and then send the file to my Docker container. The Docker container is going to analyze the Docker. This is all JSON. This is all how it's supposed to work. But what I have here, let me go back here. I have written a couple of lines of code that I am going to pick up the JSON. I am going to create a JSON object. I am going to sort this JSON object from probability, from the best one to the worst one. And I am going to show here in the command line if I detected this or not. And even move further, 81 with boxes, or 83, where I will draw the boxes there. So what I'm going to do now, let me turn this on. Let me start let me turn this on, it's on, perfect, there it is. Let me connect again to the drone, and let's run this with the 83. So go back here, it's not connected, I'm trying to connect. It's connected, and let's run the Python the 83. So this is going to start the camera. This is going to start to do a couple of things. It will take almost 1 minute to put it all together. I still need to figure out why. I know that I need to do I need to improve my multi-threading. So when my numbers there get closer to 100 and 150, it's going to start to realize in real time. As you can see, now I'm moving my drone, but between OpenCV, Docker, and everything there is still not very accurate. But at the same time, what I am doing is, as soon as I detect one logo, and you can see there that is a step one logo, I am showing there that is a logo detected there. So it's starting to get there, still connected, it's still on, yes. Still on there, yes. So we are starting to get there. If I point this one here to, come on, we are almost there, 130, 40, 50. If I point this one here, come on, up, pointing down. Every time that you see these logs there is an MVP logo detected, and after a couple of seconds, it's going to be also show it here. And the way that this works, and let me keep this with the power connected. And the way that it works is, at this moment, what I can do, I can go to the files that here, and I have here all of the images that are detected. So this is every frame that I have here is detected, and I am saving special the ones that have detected. So you can see there that is one MVP logo detected. I'm starting to move. Somewhere there in the bottom is the other detected. Somewhere there, I moved to the back. All of this info is there, and I even have, let me open this I even have the JSON file here. This is a JSON file that if I go back to, where is my Chrome? There is my Chrome. If I go back to my JSON viewer and I paste this, I can go to the viewer, and this is what I have here. This is my predictions. I have 6 predictions. This is a bounding box, 89%, so it's kind of good. This is the MVP here. Then I have another, then I have another, then I have another. All of this is available here. And again, It's not the best result here. It's not the most accurate. It's not the best way to work. I will not do this on live because it kind of break. Just take a couple of seconds until it's refreshed and it gets everything there. But it works. It gets me information. Oh, I'm sorry, this line. It gets me information. I have all of the values here. I have the bounding boxes. And you can play around. And again, it's only 20 lines of code, 30 lines of code, and it's freaking amazing. I am saving here all of the detected images, so I can go here and start to see, this is my MVP, this is the other MVP, 1, 2, 3, 4, 5. This is right now, 12 p.m., 13 minutes, which is almost right now, 2 minutes ago. So this is what I am saving, and hey, it's working. I am going to leave this here, like this, with the cable there connected. So I am getting to the end. And by the way, just to review what I am doing here, I am getting the information that I get from the from the Docker container created for an image from Custom Vision. I need to do some math here to basically adjust this to the size of my camera. I am taking the camera with this, with 640 and 40 nanometer, and then I am drawing my boxing molding boxes. And I am only displaying ones which are bigger than 75%. If I want to get smaller, I just change this, start this again, and that's it. That's why we only see, we only see here 2. Probably if I put the threshold below, I don't know, 50 or 60, I will get more. But hey, as a test, it was amazing. So there are plenty of code here, and I still have a couple of more minutes. Let's review what I did. Let's have a quick recap of what I did. First of all, I understand how a drone SDK is working. I try to understand how you have it, how you can do things, and I create my own. By the way, here are parts of the recaps. There is people, like an example, Damian Fuentes, who created an amazing wrapper on top of the SDK, and basically very simple to use. You are going to avoid everything that I've done to just import Telo, and then you say connect, then you say take off, and that's it. You have it there. You can move left, move forward, move up. This is an amazing example of how you can do all of these things. Then what is the next thing that I do? I use my camera. I learn how to work with UDP. I learn how to use with OpenCV and UDP to display the camera. I learned a little in the process to basically manage the UDP stuff. The code, you will see the code, and it's very amazing. But hey, I have the camera, and when you have the camera feed, you can do plenty of things. Do face detection, as you see, 10 lines of code, and it's working. Or even create your own content, your own image recognition, object recognition to do the face analysis, and to do the MVP recognition, and it's there. It's freaking amazing. And the last example that I'm going to do, because I still have a couple more minutes, I am going to show you how I created one that is going to detect faces, and when the face is detected and it's flying, it's going to fly the drone, and when the drone is flying and detect a face, it's going to spin. So this is the moment that my drone is going to drop into the wall or something like this. I have a video just in case, but let me show you this one because this is the one that we want to see. Okay, so let's stop this. Stop, let me pick up my drone. There is a drone. Let me turn the drone on. It's on, perfect. Let's connect to the drone. And once I'm connected, what is the number of this one? 50, perfect. Let's connect to the drone. There is the drone, there it is. And for this one, what I need to do is I need to connect to the drone. Then I also have some lines here that if I press the T letter, I will take off, so it's going to fly. With the L letter, it's going to land. And if it's flying, it's detect the face, it's going to flip. So somewhere here should be, this is the camera of the drone. So let me put this one here, somewhere here. And let me also open my camera so you can see the other camera. There, oh, it's very dark, sorry about that. Okay, no problem. You are going to see here how it flips. So there it is, the drone. Let me go here, I will press the T, and it's going to fly. So there is flying the drone, somewhere there. And when I get close, It did a flip. It was very quick. It did a flip. I don't want to make a flip again. I'm going to land the drone, press the L key a couple of times. So it's landing. The video feed is kind of detecting. I think I have so many devices here, so the video feed is there. But hey, this is kind of the end of the demo, the end of the stuff. Just a couple of resources if you want to have it here, where you can get the drone, the SDK, my post about this, how the Viola Jones post work with this, the community services stuff, and the final, if you don't want to write your own SDK, this is the one that I found. Probably there are another, but this is great. So thank you very much. It's a pleasure. You can find me here, and I will see if you have any questions. I will be happy to share my answers.
Amazing. Oh my goodness. That last bit, like the suspense of whether it was going to take off or not and find your face was just too much. I was like,
It was
I'm sorry about that.
Award for best session at this today goes to Bruno.
Thank you very much.
That was so good. So my first question, because I feel like even in just our chat for hosts here in the background, is we all want to do this tomorrow. So you shared some links there of all the different resources you use, but have you shared your own code?
Oh yes, as soon as we finish, I will give the GitHub where I start. We have everything, and feel free to go there and play around. But remember, not a very stable code. It's just to have fun. But I have fun, and I learn a lot. That's my idea.
Yeah, I was going to say you seem to be quite sort of open, which is great in this kind of new world of AI. You always say, "Oh, I'm just a developer." You shouldn't say that, but you seem to just kind of go, "Oh yeah, I found this and I found this and I found this." Do you do a lot of reading around the subject? Is that how you found all these GitHub repositories? You know, with OpenCV and then the Trello one and stuff like that.
Oh, yes, I spend a decent amount of time every time that I want to start something like this. So, an example, I haven't told the story here, but I write a couple of emails to the DGA people to say, do you have an official SDK? What language do you support? I didn't have any answer. I don't know if I'm writing the right people or not. Maybe this is commercial. I didn't have any answer. That's where I start to find. But yes, unlucky for us, there are a lot of people who are doing this kind of own research, and they publish the results, so you can learn from there. You can find these kind of things, and hey, everything. A lot of these examples are in GitHub, and hey, I am really happy to add my 2 lines of codes there also.
Okay, cool. Bruno, did you have any of these kind of projects that you were able to put in production already?
Yes, I can't speak much about this, but we did something similar with another more professional drone inside the warehouse where the drone is flying around, detecting pallets and reading barcodes, and we know at every time when the drone is doing his rounds, where is the products inside there. So there is a market here. You can imagine today that we try to avoid contact with people. If you can put a drone inside a supermarket to fly around the aisles and detect products, and you can see where is the product or not. So there is a lot of things that you can do with this. And yes, a couple of these projects are in production. Not with this toy. The toy is just a toy.
Yeah,
but with other more professional drones, and we had a couple of experience there.
The drones where you can deploy the model on the drone, then I guess.
That's kind of the idea. Yes, one of the options, I haven't shown this, is that in Custom Vision you can also export this, in example, as a very powerful model to be used with the Custom Vision kit. So you can put almost there in the drone, and yes, the drone has the intelligence there. This one, I am running the model locals, and the drone is just a camera.
Okay, still cool.
And then just finally, because we only got, say, like a minute left, you mentioned there that when it becomes, so you've just created an awesome demo on quite a small device. Love that you check the battery all the time. I found that brilliant. So even for an offline model that you put on that small device, there seemed to be a bit of a trade-off between complexity and hardware. What does that look like when you go further up the spectrum with, say, like more advanced hardware?
I mean, you can go for a $20 device like the Raspberry Pi, and do image recognition here, and it works really, really great. So if you have a big drone that you can attach and put all of the image recognition power here, you can have an isolated device, and it's not expensive one. It's not a complex one, because this is just a Linux machine, and you can do a lot of things today which are very easy and accessible. I think the main problem is when you need to move to a real production environment, how do you handle this Raspberry Pi and the drone? Lucky for us, and I'm not an expert here, there are plenty of Azure IoT things that you can do. So you can manage your Raspberry Pi using IoT with a couple of daemons, so it's part of a bigger deploy. So you can move to production to these pet projects that you can do at home. Today is easy to move them after production, but I do not know the specific details to do this. But lucky for us, I have a lot of friends who can help us with these kind of things.
Cool.
Fantastic. Okay, well, we are unfortunately up on time. Huge thank you, Bruno. That session was incredible. We have people in the chat asking for slides and code and all sorts. So this is very, very exciting. Thank you. But for now, we'll say goodbye. So thanks very much, Bruno.
Goodbye. Thank you very much.
Thank you very much, Bruno.
All right, and we'll be back in around 10 minutes. Myself and Sammy will be teaming up again as hosts to speak to Veronica.
Hey, my name's Akanksha Malik, and I'm from Melbourne.
Excellent, Sami. It's Val here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Welcome from Spain.
I'm Prasant from California.
大家好，我是卢建辉。
My Nederlands.
I'm Arafat Yassir from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Arpita Gupta from India.
Hi, I'm Matthew Renton from the USA.
I'm Joe Spizak from California.
Hi, Medin Ali Daoud, Greece, Africana.
Hi, I'm Ana Famana.
Merhaba, ben Türkiye'den Daron Yönden.
Hi there. Hi.
Hi. Hi.
Hi.
Hi.
Hi.